Thanks. And yeah, it's actually like being part of a professional broadcast. Well, I mean, of course, this is a professional broadcast, right? But yeah, really like having the queue in. It's great. Yeah, thanks, Alex. Yeah, welcome everyone. Really good to see so many people joining us on this slightly cool summer's evening. I guess if the weather was gorgeous, there'd be fewer of you. Yeah, we got two really great talks lined up for this evening. So yeah, firstly, we have Gunnar Narayanan, who's going to talk to you about Quadtree and its implementation on maps using D3, the visualization library. And then after the break, we have building high performance financial web applications with JavaScript by Pavel Badensky, who I don't think has joined quite yet, but is going to hopefully make an appearance after Gunnar's talk. So that was the high level. That was the high level agenda. The slightly more detailed one is I'm just going to give a bit of a intro about some industry news, which is hopefully of interest to you. And then after Gunnar's talk, we'll have a short comfort break, probably 5 minutes or so. And after both talks, we'll have a Q&A. So we'll leave about 5 minutes for people to ask questions. You can do that in the chat or just unmute and ask away. So before I dive into the industry news, I've just got to thank our sponsor, Pusher, who've sponsored us for years now. Alex has become, I guess, really important partner for us, especially with online. So previously we used to film the events and then we would publish that on YouTube and people could watch the material back. Now it's obviously critical that we have a Zoom link that we can use that doesn't expire after 40 minutes and that we're able to stream to YouTube and you're all able to join and participate. So yeah, massive thanks to Pusher for that. For those of you that don't know what Pusher is, it's a set of real-time data APIs. There are two products, I believe now. Is that right, Alex? So there's channels and beams. We'll give an updated slide or a slightly refreshed Pusher intro next time. But yeah, check them out. They've been going for years and they've supported us for years. So really grateful. Okay, diving into some industry news for you. This really caught my eye. I think it was in JavaScript Weekly a little while ago, a few weeks ago. A company that claimed, or a group of developers that had worked in collaboration, I think, if I remember correctly, with Google and Mozilla and various organizations to build an operating system that actually runs Node in the browser. You can do everything from order a pizza with an emoji to hire a car, whatever it is, all just through one application. And this kind of leap forward, I would say, it definitely introduces a sort of game changer for us. I mean, if you can imagine, previously it would be impossible to do something like video editing in the browser. There'd be too much latency. It would be highly inefficient. It just wouldn't feel like the right place. But what they've done is they've used WebAssembly to run the application in the browser and create the environment and various progressive web app PWA features so that it can work offline. This is a screen grab of the application that StackBlitz have built with this technology. So it's understandably going to be familiar to a lot of you, right? You're probably a lot of developers on this call, and this, as you can tell, is a fork of VS Code. This is actually a screen grab of me using it in the browser, and it was super slick, very, very clever. Why would I want to do that? Well, they have got some very compelling reasons in their sales pitch. So faster than your local environment, builds complete and up to 20% faster, and package installs are 5 times faster. I mean, I have to say, I was really impressed how quickly it installed the dependencies. You can actually debug Node in the browser right now because it actually integrates properly with Chrome DevTools. So that was really impressive. And it's they make the point it's more secure. It's in a safe sandbox. No one can access that unless you want them to. And as I mentioned before, it actually works offline, which is really clever. So yeah, I was really impressed by that. I will post a link to this and the other things I'm about to mention in the chat. Yeah, during Guna's talk. The next item that I felt compelled to talk to you about briefly is Babel running out of money, which I found quite sad. So, we all depend either directly or indirectly enormously on this tool. And yeah, they wrote an article telling the story of of their team and what's happened over the last 3 or 4 years. So you'll see on this timeline, it's not the prettiest thing you've ever seen, but it does tell the story. So yeah, they had someone, Henry, join in 2018. Yeah, at one point they had pretty good funding and easily enough to cover his salary. And 2 more people joined. I mean, as you can imagine, it's going to take quite a few people to keep something as powerful as this alive, but donations have gone down. So for a package that has 24 million weekly downloads, the fact that funding for this package is short is really sad. Yeah, and just to call out what that looks like, to fully fund the currently paid maintainers, we need at least 333,000 per year, twice what we're currently bringing in. So my message was not necessarily for you to all hand your hard-earned cash over, but certainly if you're not the budget holder, please, yeah, flag this to your boss and help fund them. It can be really good for businesses to join or back projects through the Open Collective. So I'll post the link to that in this afterwards. Open Collective are a way of, or a group that organize contributions to lots of popular projects that you'll have heard of. So yeah, I really recommend yeah, telling your boss that we need to keep these really important pieces of kit alive. And thanks for the round of applause emoji, Richard. It's good to see that, yeah, that this is landing an important point. And then finally, a little bit of self-promotion, but it is hopefully going to be really useful to some of you on the call. I've, over the last few years, had some really frustrating, niggly headaches with unit testing in different JavaScript module patterns. So I decided to write an article on Medium, which explained how to tackle some of them. So specifically, there's 2 problems that I talk about in the article. It's all about using stubs and spies. And problem number 1 is that stubs and spies with ES6, when you compile using Babel, funnily enough, probably to CommonJS, which is what the vast majority of projects do, that has a particular problem. When you compile to CommonJS, it's not possible to stub or spy on a function that's called by another one in the same module. So you may have seen the error below that I've put here, expected spy to have been called once, but it was never called. This is just, yeah, drove me nuts. So in the article, I offer an explanation as to why that's happening, a lower level and some solutions. And then the second problem, because I decided when I got really frustrated with one particular project that I was starting to switch to a different module pattern, I thought, well, I'm writing an ES6 using import, export, why don't I just use ES modules? So I switched that project to ES modules, and then I got the error, ES modules cannot be stubbed. So yeah, that was frustrating. Don't worry, it's not game over, but yeah, you may have encountered similar challenges. So yeah, I will share the link afterwards. I hope some of you find it useful. Yeah, and finally, tweet us or follow us or both. So yeah, if you want to spread the love, share any screen grabs or any quotes from today's session, please do. That would be great. Okay, I am going to hand over to Gunnar for the first talk. Alex, I imagine you'll want to count him in. So over to you, Gunnar.
Thank you, Alex. Hi, guys. So topic for me today is Quadtree and its implementation on maps using D3. So let's get started. Yeah. So here I have a section of London in Google Map. So what I did was I searched for Costa Coffee. As you know, a lot of chains are there in London. So can anyone guess the number? You can even send it in the chat. Sorry. Yeah. I'll give you a few seconds, maybe, like not much, because it's not easy to guess, I guess. 23, closer, but yeah, little bit far away. I think this is hiding. Oh, 125. You're way off me. Cool. So yeah, let's get to it. But I think no one got it. I guess that's why this is all about. Yeah. So my name is Gunaseelan Narayanan. You can call me as Guna. I'm a front-end developer in JFrog. I go by the social media ID Nirmal93 Guna on almost all the social media. So you can follow me on Twitter or Medium as well. So before getting into the topics, let me tell you something. If you want, you can take a screenshot of this slide. You can go to jfrog.co/js monthly home hub, where you can refer to my slides if you want to look in the future, and you can rate my talk. The video will also be posted there. And also we have a raffle available, so you can fill the form, and you might be a lucky winner to win Google Home Hub. So why not give it a try? So I'll give you a few seconds to take a screenshot. Okay, so yeah, so these are the topics for the day. First, let me explain what is clustering, and then we'll go on to understand what a Quadtree is, and then we'll see how to implement clustering on a map using Quadtree, and then we'll get on with the demo of a JFrog application where we have implemented clustering in our map. And then I'll talk about why we haven't considered all other map APIs available, right? We have a lot of things available, so why not take something which is existing? So yeah, that's the topics for the day. So getting on with clustering of markers. So the right answer is 17. As you see here, the map looked cluttered a little bit, right? So there were a lot of chains available. I just searched for it, and it showed everything as a marker, each shop as a marker, and everything was cluttered. What if there are thousands of available, whatever you search for, Starbucks or whatever? What if there are thousands in the map, and how will it look? So it will be like a sea of markers, right? So you don't want it that way. That's why we need clustering, where you can group some things together which are close by, and when you zoom on, it can expand as you wish. So what are the advantages of clustering? It obviously gives you a visual help, because as I said, you don't want to see a lot of markers on the map, and you don't get confused where you're looking at, and you won't basically see the map, I guess, if you're having a lot of markers that covers the map. And one more thing is you can do heat maps with clustering. So currently I showed you about markers, but what if instead of markers, you can change the color of a portion based on the concentration it is getting, right? So if a lot of markers point to a particular location, you can just change the color and show it in a different way. That's how heat maps work. You would have seen that in weather forecasting in many places. And last but not the least, performance improvement. See, each marker in SVG is a node. It's a whatever it may be, it will be a node, obviously. So when you have thousands of markers in a small place, it will obviously affect the performance of the browser, because there will be a lot of elements that on the DOM, and it takes up the space and it becomes slow. So that is one help it does. You can, when you clutter, you will have only one marker for a particular group of markers, so that obviously improves your performance. So that is one thing you have to consider when you are doing clustering, right? So this clustering should be based on the zoom level. As you see in this image or GIF, when you're zooming in, it has to calculate again and group the markers accordingly. When it was zoomed out, it was showing 15, but we zoom in, it was going to its own location, right? So that is one important thing you have to consider, right? So yeah, let's move on to Quadtree. As you all know, Quadtree is a tree data structure algorithm you would have studied in your school or college. So what a tree data structure does is it has a parent and it has some nodes as child nodes, right? So each parent node is split into 4 in Quadtree. You would obviously guess quad is nothing but 4. So each node will be split into 4. So each parent node will have 4 child nodes. So that's what Quadtree is. And why Quadtree? So Quadtree is nothing but uh, it is nothing but you're having a space, and you're going to separate it however you want. So when you're going to separate it by 4, it can be manipulated and accessed easily. Let me show you why. Consider this square. So consider the whole square as a parent node, and you're going to split it into 4, right? What happens is each inner square becomes a child. So in the same way, that inner square can be split into 4, and that forms a parent node, and again it goes on. So in a circle you can't do that. If you take a circle and split it, you will always have left out spaces. But when you have a square, it's easy to split into 4 and go on inside. So each level, at each level, you will have you can split it each square into a number of squares, four different squares, and so on. So that's why it's easy to be accessed. So when you have a point on a particular square, it's easily you can access only the parent node, and through that you can easily get to the child node. So I have a code pen where I can show you how how Quadtree creates its branches. So consider this as a square. I'm going to put points here, and let's see how the branches are, the nodes are formed. So first, let me put one point here. Next one here. Last. So as you see here, we have formed 4 different points. Each one represents one child, right? So the square is split into 4, and we have got 4 different childs now. Let me split this one into 4 more again, right? As you see here, this one part of the square is again split into 4, and 2 is lying on. If you see, these 2 are lying on a smaller square, and this is on a separate square, and this is on a separate square. So this is how a Quadtree algorithm works. Wherever you place the point, it can easily split it into different nodes. So when you're going to search for this particular node, it knows where to look at. It already lies on this part of the square. So you have already eliminated 3 of the nodes. You're going to search only through this particular node. So that's how your search will be streamlined. You don't have to. That's why Quadtree does search faster than any other algorithm. So that's it about Quadtree. So let's see how we can implement clustering on maps. So that's what this is about. Why I showed you why Quadtree is the best choice for clustering or grouping of points. Now let's see how we are going to implement it on the maps. So a map is nothing but a graphical plane which has x, y point. It starts from 0, 0 and goes to x, 0 or y, 0 to x, y, right? It's you have a rectangular square. It'll that's how the graphical plane works. And what you're going to do is D3 has a Quadtree API which you can easily use, and you can send the points, just an array of points you can send, that will return back the Quadtree structured array. So that's what you're going to do. And then what you're going to do is consider your plane as a big rectangular square, and split it into different grids. right? Each grid will be traversed, and you can check whether a point is lying inside a grid or not. Okay, so based on the level, you will be based on the zoom level, you will be having the size of the square, and if a point is lying inside the square, you are going to group it. It's that simple. And once you have grouped the points, you can add one marker to it and display it. You can add a number or however you want, heat maps or however you want. So let's see this code here. The data, sorry. So the data points is the points on the map that you already have. You're going to pass it to the D3 Quadtree API. And this Quadtree will have its methods and the points calculator. So what you're going to do is you are going to give this cluster range. The cluster range is nothing but the size. So this will be calculated based on the zoom level. Suppose you're fully zoomed out. The cluster range will be a little big. It will be a bigger number. So a large number of space will be grouped together. And when you're zooming in, this cluster range will reduce. Based on the zoom level, you can reduce the cluster range, and the square will be smaller. So each time when you zoom in, the size of the square will be small, and only those markers that are going inside the square will be grouped together, right? So width and height is the remaining, or the plane size, the SVG that that is available, that is the width and height. It will be calculated automatically. And so whenever a point is lying inside, this Quadtree.visit will tell you if a point is lying inside the square. Okay, you just have to pass the details, whatever you get. And based on this, whenever a point is passing inside the particular square, or more than one point is passing inside a particular square, what you can do is you can calculate the middle point. Suppose there are 2 points, you have to calculate the middle point as well to show the marker. You cannot, if you're showing a marker, right, you cannot show it on one place or wherever you want. You can just calculate the middle point easily with the height, edge x and edge y, right? You know the sizes of the edge x and edge y. With that, you can easily calculate the middle point. So you're going to place the marker on the middle point. So yeah, let's get on with the demo. So this is a JFrog platform where we have a dashboard showing a map of all the interconnected JFrog platforms between them. So here is the map which has markers on Buenos Aires, Mountain View, and we have 3 on India, and we have 2 on Israel. So and we have we show the status of the the platform and how much storage it has used. And replication is concept of duplicating data from one platform to another. So you can even see that status, and the license and the services points to the other products that JFrog comes up with, right? So let me show you how we have implemented clustering here. So as you can see here, all these points are placed in India. Suppose the square is this big, all those appearing inside, all the markers inside the square are placed inside a cluster. So this cluster shows the number 3. And when you hover over it, we show the details, other details, right? So let me zoom in here. As you can see here, when I zoomed in, the the range of the cluster, range of the grid is reduced. So this marker has already fallen out of the other 2 markers. So it will just go outside. It will go to its own place. Previously, it was in the middle, but now it's fallen apart. So let me zoom in more again, because this has 2 markers. These are also close by, but little far apart. So as you see, when I zoom to the maximum, it has gone to its own place. So the cluster, the range of this marker is different to this marker. So that's why it has fallen apart. There is also one more thing. As you can see here, there are 2 cities, Netanya and Tel Aviv. They are separated by just 30 kilometers, right? So our zoom is like, I have given a zoom level of 8 maximum. So we can't zoom in above 8. So it won't fall apart because it's so close to each other. Since the zoom has already been done, it's always falling under the same square. So it won't fall apart. So that's one thing you have to look for if it is fine by your standards or what you're looking at. So that's one thing. So that's it about the demo. So let me tell you why I didn't use any other map APIs and libraries. As you know, there are a lot of very good map APIs, Leaflet, Mapbox, and Google Maps API. They provide a lot of functionalities, even clustering. Yeah, Leaflet, for one thing I know, provides clustering with its API. So why didn't I consider all those map libraries? The first thing is framework granularity. As you know, all these map libraries, they come with their own set of modules that they include. So when you have an application where you are restricted to the number of modules or how heavy your application is, you might have to consider that as well. You cannot use library which, because these have Leaflet, Mapbox, Google API are really complicated. They use a lot of libraries along with it. So that's one thing, it helps. And you are restricted to the APIs available. Suppose if you want to implement something new, and if the APIs don't support it, it will be difficult for you to go ahead, right? If you're doing it on your own, you are bound to your own imagination. You can do whatever you want and however you want. So that advantage you get. And integration with other visualization. So suppose you see an animation library, that's very trendy and very catchy. So you want to do it in your map, and it the other APIs that it might not support it. So that's one advantage you have. So basically, if you see our application, it's very simple. The map is not very complicated. It's very simple. I'm not showing a lot of details. Just a plain map that just shows the markers and some details that we want. So these kind of situations, you don't have to use a library to be specific and involve a lot of complicated stuff. You don't want that. It needs to be simple. So that is one thing. Yeah. So before winding up, let me tell you about JFrog Swamp Up. We have a DevOps conference, as I've said. JFrog is a a DevOps platform that we provide end-to-end automation and software development. And we have a yearly conference where we have breakout sessions, and a lot of leading companies and front runners in DevOps participate. They have their keynotes as well. You can participate. It's it's really nice. And the EMEA June is on June 2nd to 3rd. So if you want, you can just Google Swamp Up Meetup JFrog. You will be able to find. So yeah, that's it for me. Open to questions.
Yeah, thanks so much for that, Gunnar. That was great. Yeah, and I can't think of a time in the last few years that we've had a talk on how to handle two-dimensional space and using Quadtree. So that's really, really good. Hopefully a lot of other people on the call really enjoyed that too. I'll open it out to the floor then. Does anyone have any questions? Don't be shy. Any questions, anyone? I have a couple if no one else does, but I'll let you go first. If you don't want to speak, feel free to type in the chat. No? Okay. Yeah. Okay. Well, I've got a couple for you, Gunnar. So yeah, firstly, how did you actually settle on Quadtrees as the solution when you were working on this problem?
Okay. Yeah, I just did a research. Actually, first I was not planning to do it on my own. I thought, let me try, a library like Mapbox or Leaflet. Leaflet was the one I considered a lot, but it's a little heavy, to be frank. Our application is already a lot of things, and don't want to load it up with another library that brings up a lot of other complicated stuff as well. So then I thought of researching to understand how clustering is done, first of all, like how the other libraries do clustering. So that's what I wanted to do it, right? So we already had a map, we just wanted to do clustering. So when I searched for it, what I predominantly what I got was Quadtree. Quadtree is available in D3. That is one big advantage. We don't have to do it on our own. D3 already provides it. So that's the path I took, and that's how I got to make it work. And yeah, a lot of help I got. I didn't do it on my own. There are a lot of blogs that you have to search and find out. Take whatever you want and build one that is suitable for you. So.
Yeah, sure. Well, it's good that you mentioned all of the other support you get out there, right? This is the thing about being a developer, particularly a web developer, right? This is that
Exactly.
without the community, without all that information out there, with all that without all that knowledge sharing, it would be certainly a lot harder. We've definitely been reinventing the wheel a few times as well, I think. So yeah, you mentioned that D3 has Quadtree, a Quadtree API. What other features of D3 are you a fan of? Do you use it much?
Yeah, actually, not like, to be frank, we use D3 only through other libraries. We don't use it directly. Like we have a chart visualization library called Billboard.js where we use the base is probably D3. So that's so only in maps, I guess, we have used D3 directly only for this map section, but other than that, nothing directly. Maybe somewhere if you want to do some modifications, we use some of the things like accessing the DOM is little easier using D3. So some of the places, but not much. Yeah.
Yeah. Okay. Yeah. Cool. Anyone else want to ask Guna a question before we go to the break? Oh, I can see Pavel, our next speaker's joined. That's a relief. Otherwise, you're going to get my backup presentation. But yeah, anyone got a question? Hopefully, you all found it informative. Well, I'm going to give you a round of applause, Gunnar. Doesn't look like there's any more questions, but yeah, really appreciate that.
Thank you, guys.
Yeah, really good talk. Thank you so much. I can see a few clap emojis for you as well. I guess, yeah, everyone's doing this purely visually today. Brilliant. Okay, well, yeah, thanks again. And we'll take a 5-minute break. So, well, we're just at 10 past now. So I'll see you all again at 7:15. I think Pavel's speaking, and I think you're muted, Pavel.
Yeah,
there we
sorry,
go.
I was muted. Yeah.
No worries. Right, the floor is yours.
Okay, cool. Yeah, thanks for having me here. My name is Pavel Badensky, and today I wanted to chat about building high-performance web application, specifically financial web application with JavaScript, something that we've been doing for the past over 4 years in our startup. We started the journey actually more than 4 years ago, and yeah, I've been going since. So the presentation, so a bit about me. I'm a CTO and Pricing Monkey. I'm one of the co-founders. So I've seen this. I've been here since day zero. So this is going to be a journey of experience from that journey. You can see my Twitter, email. You can reach me out on those channels. I'm also a mentor at Meet a Mentor. If you haven't heard about it yet, do go ahead and check it out. It's a really cool and free community. I have nearly 15 years of experience in building software. I come from Java background, where I spent quite a bit of my past, and I became a JavaScript developer 5 years ago when we started the business. We're still going now. I'm a generalist, so I do love design. I do like software philosophy, or all the different programming languages and all sort of problems. But I do love performance engineering. My love of performance engineering started relatively early in my career, and since it's really have been a thing I kept being drawn to. So this presentation is our journey in 4 points. Something to say is my style of presentation is that I do tend to overwhelm people with information. So do take notes, things that you find interesting. Sorry, 1 second, let me just have to disable my phone. So do take notes if you find something interesting. And feel free to reach out to me for more details, or if you want to hear more about any of what I'm going to talk about. It's going to be a bit of, like I said on the meetup page, there's going to be a bit of a buffet of information. I was trying to kind of cover for people who are just beginning their journey and people who are quite experienced. So yeah, get ready for a bit of a roller coaster. So first one, don't get distracted by other people's problems. This presentation included. I think it's quite relevant when you go to all sort of, and I've certainly been a victim to all sort of conferences and presentations. You see, the new cool thing, the new technology, and immediately jump into it. And it's actually not necessarily the solving the problem your project might want to be solving. Everybody has their own problems and their own challenges, and the solution might not work across the different contexts. Now, we are a specialized software as a service platform for financial analytics, and what that means is that our main JavaScript bundle is 6 megabytes, and that's 1.5 megs compressed, and everybody will probably run away screaming at this point. We're not bothered at all. We failed a Google Lighthouse test. This screenshot here is from Google Lighthouse, a tool that Google has in Chrome that can measure how well behaved your website is. We got 9 out of 100. First contentful paint, 5 seconds. For some of you, this might be absolutely horrific. Our customers go onto, we have a small number of high-paying customers. They go on our platform and they open the page and they stay there for, their day, and maybe refreshing a few times in the day. So it really doesn't matter that the page takes a little longer to load. So yeah, I know that 99% of the internet does care about that. We don't. So a lot of information that we find about performance, when I Google performance, website performance, or things like that in Chrome, I actually find things that are not necessarily as interesting to us. Yeah, majority of performance suggestions don't apply to our project. So the screenshot you see here is about Prometheus client. We do use Prometheus. Interestingly, actually, we do report metrics from Prometheus to metrics from each of our users. We report to Prometheus. I'll say a bit more about that a little later. So we basically track every single customer instance. We treat it as a separate node because we do computation on some computation on the client's machines. We do also track need visibility in performance of how it behaves on each user's computer. So we push metrics from our users' browsers to Prometheus with a Prom client library, which actually we forked in order to deploy it in the browser. And Prometheus does not encourage, and they say it's an anti-pattern, but it has worked for us for 4 years. We have been recently looking at another technology that I do recommend you to check out if you're using Prometheus and struggling. You might be interested in a tool called Victoria Metrics, which we've been recently looking to migrating to, and it looks very, very promising. And it, among other things, does support the push that we've been missing. So yeah, I mean, first thing that I would like to emphasize here is a lot of the time you might be using an anti-pattern and it actually works for a long, long time. So we've been doing this for almost 4 years, and only now with scale are looking into a different solution. So context also have a longevity. I mean, Facebook has been using PHP and for a long, long, long time. So everything, every performance suggestion will apply differently and might have a different context span as well. Our performance challenge, as I mentioned, is thousands of financial computations inside the browser. So here's a screenshot from Grafana. So these are the metrics we get from our users. And what you can see on this screenshot is that we calculate calculations on users in the users' browsers on their computers. There's around 200 calculations, each taking a few milliseconds, but 200 calculations every second, and that's something that we worry about. So we worry about what happens after user waited 10-15 seconds for the websites to load. We worry about the next few hours, what's going to be happening as our financial data pulls a new live information, has to recalculate and recalculate and recalculate. So what is our problem? Our problem is called, for us, it's optimization for a CPU-bounded situation with high event throughput. So what we deal with is 500 to 1,000 Redux actions per second. That's both system UI and non-UI. So as you might guess, there's not going to be a lot of Redux. There's not going this many Redux actions coming from the user. A lot of it is actually being triggered by the system in order to manage, incoming data and all sort of bookkeeping that is connected to handling live market exchange updates. So yeah, really, I'll be talking a bit more about how Redux handles that later, but this is our reality. And another one is the 10 to 2 computations per second. So that's each other runs 10 to 50 milliseconds, which may take around 100 milliseconds to 5 seconds to perform a full sweep. So to recalculate 100 computations with this throughput to recalculate the whole user's context, the whole user's workbook, we might need up to 5 seconds. So of course, we offload it to a web worker, and that's something that's very specific to our use case as well, using web workers and offloading that CPU-bounded problem to a web worker. Otherwise, some of you, as some of you know, node.js is single-threaded, so otherwise we would have absolutely no time for the user to be able to interact with the UI, with the user interface. So we need to move that to a separate thread, and that separate thread is in the web worker. So what's CPU bounded? CPU bounded is a fancy term, and when I've heard it a few years ago, I was really I could never really get it. It sounded very exotic to me, but it's actually quite simple concept. It basically means that your program is mostly bounded by CPU. So your program will go faster if you get more CPUs, or if you get your program run faster on those on the CPUs you have. It means that the emphasis in CPU bounded is that in comparison to any other resource in a computer, like memory or drive or network, they don't matter. So you could have, if you have a CPU bounded problem, you could buy 100 terabytes extra RAM, but your program will actually still run the same speed, because the problem with this is with the CPU rather than with other resources. A lot of, so to use this, to connect it back to the reality that many of us have every day, is most problems, the 99% problems that I mentioned earlier, a lot of those problems are actually part network bounded, part CPU bounded. So the faster your network, is, the faster the the website might render. Of course, the story is not as simple, because another thing with boundedness is that things kind of tend to, when you fix one problem, as in general in software development, when you fix one problem, another problem arises. So what happens is when you fix a network boundedness, you often introduce another boundedness. So that happens with websites often, right? Like, so you make your JavaScript to be delivered to the customer really quickly, but once it's get delivered, they open it on its mobile, and then the mobile has a CPU that is too slow to load it quickly. So now you have a CPU bounded problem. So something to say here is, it's going to sound really obvious, but it's like 60% of success in performance optimization is to understand what's bounding your problem and at every specific time. So you're actually spending your time smart solving a boundedness that's interesting. So there's no point optimizing how speed of your website if it actually takes long to load over the network. So that's something to remember. That's like essential thing in performance optimizations. Yeah, so a bit about JavaScript. JavaScript is faster than you thought, but slower than you wanted. And what I mean by that is JavaScript actually, there's a lot of optimization that went into JavaScript, and it's actually a much different story when we started 4 years ago than it is now. It is slower than, it's faster than you thought because there's a lot of optimizations. So the JavaScript that you load actually gets optimized to a lot of the time to assembly code and to C. So things can run, especially when you run smaller bits of code, similarly to what you could achieve with C and languages like that. It's slower than you wanted is because as your code base grows and as the size of your project grows, it's much easier to break those optimizations or make those optimizations more difficult for the JavaScript engine. So yeah, so as you can see here, these days JavaScript is pretty fast. Unfortunately, JIT, which means just-in-time optimization, comes with caveats. Oh yeah, I didn't a bit about JIT. So the thing that I said, that JavaScript gets loaded as JavaScript and then gets compiled to assembly code and to bytecode and to C. That's called Java just-in-time optimization, and Java does the same thing. So actually, behind the scenes, the code gets sped up, gets compiled into very fast machine code, and that's happening on the fly. That's why it's called just-in-time. In comparison, languages like Rust, Go, C, C++, they get compiled to machine code, and that's it. They're super optimized at that point. So they don't go through this intermediary step. And the JIT, the just-in-time optimization, happens when you run the code. So that's important to remember. When you run your JavaScript, when the user loads it on their computer, that's when the optimization happens. So something that you see on the screen is just merely assigning a function, math power function, to a variable and then calling it will slow it down. And that's called to some I dug it up from a blog from 2013, so this might not longer be a case, but that was a case, and there's a lot of things like that still in V8. A lot of these things get fixed, but those are the type of challenges that you get. That some things just are totally unintuitive. But unfortunately, the bytecode, when JavaScript is compiled, the bytecode changes, and the engine is not able to optimize it out anymore. And in this example, you can see that the slowdown is 1 order of magnitude, so it's 10 times slower. There's some more practical caveats. It was pretty big a few years ago when V8 update accidentally broke React. There was some interaction between different functionalities, between different features, prevent extension back in V8, and suddenly React, when executed on a complex use case, would run slower. You can read more about this online. It's a pretty in-depth problem. But also, what's important to kind of mention here is that it's the you might not have to deal with this sort of problems day to day, but they do matter in case of frameworks or libraries. So things that get called a lot under the hood. So where your business code, in your domain code, in your high-level code is not going to be super important. But in the lower you go in terms of your architecture, the more relevant that might be. Of course, as usual, it will depend on your project. Other challenges. So here's going to be a big mishmash, big all-you-can-eat buffet of examples. So there's a lot of string representations in JavaScript. I mean, I found this on Stack Overflow. I'm not sure if I haven't been aware before that, but actually, you have one string in JavaScript, but this can, depending on the context, be represented in actual V8 engine in 10 or 15 different ways. And you actually, it's very difficult to know which way it is. And all those representations have different performance characteristics. So something that I wanted to really put a warning here is be careful. That's another point, to be careful with your micro benchmarks. Because what we noticed a lot is we run our micro benchmark and it has totally different performance characteristics than production code. Because production code might run on a different string, and you don't even know that it's running on a different string because it's very difficult to inspect. So you have to be very careful when you try to optimize production code and you try to create your micro benchmark, and you're like, oh, I optimized the hell out of it 10 times faster, and then you deploy it, and actually didn't change because it used a different representation and there was different behavior in a JIT optimization. So be very, 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 very careful with micro benchmark. I can't emphasize it bad enough. Like 95% of the time, I see a micro benchmark. I'm like, no, it's wrong. And it might sound a bit arrogant, but unfortunately, that's the reality. It's very difficult to do these things. There's other things that hurt us a lot. Is there's no hash code in string, and there's no interning. Interning is a process when you can flatten a representation into faster representation, something that Java has. And a hash code is a very important feature when you use data structures like maps and sets. It hurt for us. It hurts us a lot. A lot of array representations. Again, this comes with the same caveat. Be careful. You think you have one array. You think you did your micro benchmark, but actually you have all these representations, and actually they will run with different performance characteristics. They can be up to 5 times performance difference between them. Something that many people are not quite aware about: object polymorphism, megamorphism. So this is that Java doesn't have, and this is one of the. If there's one thing to remember from this presentation, it might be this. So because JavaScript is dynamic, it optimizes based on execution. So JavaScript will optimize your code based on the shape of the data that comes into the function. So if you call your function with just numbers, JavaScript will notice it over time and it will say, oh, amazing, you're just giving me numbers to this function add. That I'm going to optimize it into very efficient machine code because you're just giving me numbers. But if you have these multifunction methods, or you actually using your methods a bit haphazardly, and you give a string, you give a number, you give a boolean, you give an object, JavaScript will be like, okay, dude, I don't know what you're giving me. You're giving me different objects. I'm just going to use the least efficient code so I can handle all these different cases. So that's something to remember. Things are optimized based on usage. So making it obvious how you're using it will make it faster. Will make it faster for another programmer as well, because having things that are like a Swiss knife are actually difficult to understand by other developers on the team as well. And a tool that's really, really cool to check out for this if you're interested, but be careful because you can get stuck for days and days with this and it might not be relevant for your project. It's called Deoptigate. It's a really cool tool to see how your objects, how your code gets optimized or de-optimized. Oh yeah, something that I wanted to add here very quickly is the megamorphism also applies to dictionaries and objects. So a bit of trivia. I don't know a bit of trivia is like if you line your keys in an object different way, this will be actually considered a different object in JavaScript. So if you say first name and last name in your object, and then you spread it, and then you add first name second, this will actually be different representation. So if you're using spreading a lot in your and you have large objects and you're spreading a lot in your project, this will have impact on performance. Something more relevant to us, again, slow data implementation, something that is kind of interesting because there's a bit of a tension between us and the rest of the world. Like I mentioned earlier, we want JavaScript to run really fast on those CPUs. The rest of the world is kind of like happy with, and rightly so. Is WebAssembly an alternative? Everybody keeps asking me that. Maybe. I'm very skeptical about it. Something to really emphasize here is WebAssembly is still JavaScript. Is still the same engine. So WebAssembly still runs in a V8 engine. There is some opportunities for writing more optimized code in WebAssembly. You can maybe scale your code base better to be able to leverage the just-in-time compiler and optimizer optimizations, but it's not a silver bullet that everybody says it is. And also, there's still a lot of things in WebAssembly that aren't quite there. For more details, there's a presentation that explains it in depth. It's half an hour presentation just focused on this topic. Okay, so that was JavaScript being fast. Now pick your battles. We chose React and Redux. Maybe you could have chosen something more lightweight. We're quite happy. Something to kind of was a takeaway for me. It's okay to choose a popular solution. We have evolved some of the popular libraries we use. We have evolved our asynchronous management, for example, a lot. We used Redux Saga for a while. We used Thanks. Now we use some homegrown solution based on RxJS. But React and Redux stayed with us for a long time, and it kind of is just enough. You can get used to living with it. We use, on top of Redux, we optimize for performance, of course. So we use Immutable.js, which we still use it, even though I know the rest of the world is kind of walking away from it, but we do really need it for performance. I mean, we're quite sad that it's half abandoned. Reselect quite extensively for creating our transformers and a few other tools. Something we learned about React is not necessarily very reactive. I'm very sad about this. There's no built-in debouncing of rendering. So you basically can't say, okay, if this component gets called a lot, just ignore, ignore 90% of the renders and just render every 200 milliseconds. Worse even, there's no debouncing of prop updates. Many of you may have not even come across it. It's very specific to us. If you're calculating props is very expensive, you actually do want to calculate your props, for example, every half a second or every 1 second. We use lazy data structures to facilitate that, so it's a bit of a hack. I've read recently that apparently somebody come up with a solution with React hooks, so maybe we're getting there. But this one was very frustrating to us for a long time, because there is a way to debounce, and a lot of people do this debounce of rendering, but many don't get this problem of like, okay, but what if I need to debounce my prop updates as well? But overall, we're quite happy with React, and it's with the few workarounds that we have, it's working out very well for our use case. Okay, so interestingly, last but not least, great performance will always start with great design. This is a massive topic, so I'm only going to mention a few things here. But first of all, focus on good architecture, good design first. I see some people, optimizing their algorithms and making like really efficient solution and saying, "Hey, look, it's really fast," and you can't really then maintain it or read it. And there's a lot of like hacks and tweaks, and really what's important if you want a long-lived solution, you wanna optimize for fast feature delivery, right? So performance is just one of the requirements. So you want to write a performance application so as performance as possible, but not more. So you kind of wanna make sure that you can write your features as fast as possible, and at the same time optimize where it's necessary, and not even 1 inch more. So yeah, can't back, make it work first, refactor, and only after you measure, make it fast. And when we optimize, we always optimize systemically first and tactically second. So what I mean by that is you want to do optimizations that redesign, change your design in a way that's still very readable, but faster, rather than doing one of these, okay, let me use these tricks to make my algorithm go really fast. Those, you should always, be very careful and do as few those tactical, local optimizations that make your code look worse. You should be very careful with those, because they will hurt you. This is a screenshot from the Optigate. This is what it looks like. Try it out. It looks a bit cryptic, but it's a very, 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 very useful tool to understand how your code gets optimized. And you can see there's a very complicated code from some parser, Babel or something like that. And you can see the code that's complex to read by your fellow developer actually will be difficult for the machine to execute. A lot of people don't, or even you don't even think about that a lot every day, but the simplicity of the code translates to simplicity to read, but also translates to simplicity to optimize. So if you keep your methods relatively short, if you keep your objects simple, if you keep your design well factored, you're probably potentially just getting a faster application. Evolving great design, topic of 1,000 presentations. So we use TypeScript. Perfect, best tool for fast code because it deals with megamorphism that I mentioned earlier. It helps you create predictable design. It helps you manage a complex code base. So if you follow the patterns that TypeScript advises, actually, you're much more likely to get a nice performing, well-performing application. Something that we took a lot to learn, and I would definitely recommend you don't make the same mistakes as us. That the book Effective TypeScript wasn't there when we started. It's there now. If you're using TypeScript, it's an amazing source of knowledge. We had to learn a lot of it through our mistakes. Monads, really useful for managing complexity. Something that we use to handle a lot of the time to represent exceptions. So we use either monad rather than exceptions. We use option type to deal with nullability, and other monads to basically encapsulate the complexity. Something that's I've not seen as popular in JavaScript community, but is being quite popular in Java, is especially for us, we have a monolith, because most of our application is a tick client that gets deployed on user browsers. So it's very important for us to manage dependencies in this monolith very carefully. So we use Dependency Cruiser, which basically allows you to manage dependencies between different modules, and not for it not to get out of hand and become a spaghetti code of everything talking to everything. We built a thin layer on top of it, which we got inspired by ArcUnit. ArcUnit is a solution in Java, which is much more extensive, but you can borrow from that tool in order to build your simple domain-specific language for dependencies. Yeah, and we do leverage domain-driven design, for a way to making sure that our code base is close to the actual problem, domain problem, and to manage architecture at scale. So in order to factor our modules, to manage dependency between them in a sane way. I mean, something that's really useful with domain-driven design is if you have your modules structured around domain concepts, you know that if there is a dependency between modules in the code, there should be a dependency between modules in the real life. So when you see there's dependency in the code, but when you look at the real life, there doesn't seem to be a relationship, you should say, okay, something is wrong with our code. So it's really useful in that. That's one way how domain-driven design is useful. There's many other ways. If you want to start simple, the best way to start, I think personally, is to check out DAX, which is a library for helps you start this journey in Redux. Sorry, just very quickly, some water. So yeah, in summary, don't get distracted by other people's problems, including this presentation. You might have a different problem than other people, and that's okay. JavaScript, faster than you thought, because a lot of things get optimized for you, but slower than you wanted, because if you're not careful, a lot of things will not get optimized, and it will remain slow. Pick your battles. You don't always have to have a new shiny technology. You don't always build something yourself. You can just pick the most popular thing first and then iterate. And last but not least, remember that great performance, there's a lot of tricks to great performance. There's a lot of knowledge how to optimize things, but you start with great design. Actually, things might just get optimized for you most of the time. And even as you go, optimizing things is gonna be much easier. thank you. That's it really for the all-you-can-eat buffet of tips and tricks from Performance World. And yeah, if they have any questions, comments, or observations.
I think Chris. Thanks, Alex. Yeah, I think Chris has got his hand up. Chris, do you want to ask a question?
Thank you. So a couple of questions, if I may. First of all, so you said you were doing it all in TypeScript. Have you got any tips in terms of linting or compilation rules that helped you with performance? Or because I mean, one of the examples you gave, I didn't think that would compile in TypeScript because obviously it's a statically typed language.
Yeah. That's a very good question. I had to think long and hard. So I don't know. So it's so one thing that comes to mind is I'd have to give you a more comprehensive answer. I'd have to think more, but something that I could probably say off the cuff is there's an interesting problem with spreading that I mentioned. So when you spread objects, you actually create a slightly different object representation. And so if you use spreading a lot, you will actually confuse the V8 a lot. So you can very easily think that using the same object, but V8 still thinks it's a different object, and it will basically de-optimize all functions that that get those representations as arguments. So the way to deal with that in TypeScript is to use classes. So if you just use plain dictionaries, you can always like reshuffle them. So when you spread, basically when you spread, things kind of move around properties. I don't know if that kind of makes sense what I'm saying. But when you use classes, classes always have fields aligned. So fields will always go in the properties of a class will always be in the same order. So that's one way to leverage TypeScript. Now there's a small trick here that I'm going to sell you on. Okay. Is you need to put a secret symbol to your class, because actually many people, sorry, I didn't know that. Many people don't know that. I didn't know that initially, but actually there's a problem with TypeScript that you can actually in TypeScript, you can, even if you define a class in as your argument of your function, you can still pass a structurally identical structure. So for example, if you use instance of in that method, you think, oh yeah, I can use instance of, it's a class. No, actually TypeScript will accept a non-class instance. And there's a huge argument on GitHub about this. So in order to like make sure that this is really that class, you can put like a secret symbol property that's read-only and private, and then you'll only be able to use it like that. But that's like one example of how you could leverage TypeScript. We actually leverage TypeScript this way to manage this megamorphism problem.
Okay, thank you. And the other question is probably, I'll paste it in the chat because it's more general and not directly JavaScript related.
Feel free to reach out to me as well if you want to kind of have
thank you
more in depth.
That's brilliant. Thank you.
Good stuff. Yeah. Anyone else got any questions? No. I mean, I've got a couple, Pavel, just before we wrap up. Really interesting use of web workers. I'm always looking for opportunities to process things elsewhere where possible. Have you got any other uses for web workers that you could just share with everyone? What other maybe CPU intensive processor can we run there that don't need to be in the main thread?
Yes, that's a really, really interesting question. So So another thing that we do is we actually do our WebSocket communication web workers.
Okay.
If you have a lot of messages coming in, parsing those messages from string to JSON representation can be slowish. But then there's a trick that when you transform things from the web worker, they get actually sent as a binary, like some sort of efficient memory representation, binary representation, something like that. I don't know the details, so I'm going to be hand-waving a lot. But actually, it's already a binary representation. It's not string. So what we do is we have a very, very small web worker that its mere responsibility is to parse those messages from WebSocket in JSON strings, and then send them on a very fast binary protocol to the main thread. So that's one thing that comes to mind. Something that's a bit of a shameless plug is we wrote as a simple actor library for communicating with web workers. Library is named Tangi, which means younger sister in Kannada, which is my wife's language. It's a joke because Akka, which is Scala, a solution for actors, means older sister in that language. So that's something we struggled a lot with web workers, for example, is doing this orchestration communication bit. So we wrote this kind of very thin layer and sort of wraps up everything. And you just kind of you just have promises. You just send a message and you get a promise rather than having to deal with the channels and all this stuff.
Yeah, awesome. Yeah, I mean, I have found a few nice uses for it myself, especially with apps that are doing audio and visual processing or manipulating the DOM as well as playing back some audio. I might decide to delegate certain processes to a worker. Yeah, brilliant. I mean, one more question for me.
Oh, yeah, that reminded me just very quickly. I know that
that's
going to be very quick. I know that Google has been working on some solution to do DOM. Full DOM rendering in the web worker. I don't know where that is at, but I was really excited about that 2 years ago.
Right, cool. Okay.
Yeah. I'll look it up and I put in the comments what the name of the link to a GitHub repo for that.
Yeah, great. Yeah, thanks, Pavel. Yeah, one last question for me. So you mentioned that you used some kind of I think a fork or something of RxJS or something that you said that you use instead of Redux sagas. I didn't quite catch whether that was for application design reasons or whether it was for performance.
That was for application design reasons.
Right.
Yeah. RxJS is okay. So that would start a very, very long rant. So I need to be careful. RxJS is a very complex machinery, and I've been trying not to be too arrogant, but I've been in software for a while. And I find RxJS very complex, and we've been using it for 3 years now, and I still find it very complex and difficult to test specifically and to reason. So we built a layer on top, which is also open source, but maybe not explained very well. We built a layer on top, which basically reduced the use of operators to minimum. And I think the most problems we had with RxJS is from encoding a lot of logic in the plentitude of the operators, which all work differently under different conditions.
Yeah, and then made it harder to test.
And made it harder to test and reason about.
Yeah.
And we got really weird, issues when refactoring or.
Right. Well, this is still really might not be performance related, but still really useful information for everyone on the call to hear for sure. Yeah, brilliant. Well, I'll just give everyone one more chance to speak or to offer a comment or question. Anybody? No? Okay, well, in that case, I'm going to wrap up by thanking profusely our two brilliant speakers. So yeah, thank you so much, Gunnar, for your talk earlier on Quadtree and D3. And yeah, thank you, Pavel. Yeah, two fantastic talks, another great event. Thanks everyone for joining. I think we've a few people have dropped out already, but yeah, it was good to see your faces or your avatars. And yeah, look forward to seeing you next time. So yeah, many thanks to our speakers. Yeah, take care, everyone. Have a very good evening. Alex, thanks a lot.